Hello friends, welcome to my YouTube channel Code Paneer. In this video, we will discuss about data type, float and double, and this is tutorial number 9 in the series of basics of C programming. So let's start our video. Before diving into this video, we will see our overview that what are the topics that we will be covering. So the first point that we will be covering is to introduce ourselves to the float and double. So we will be introducing ourselves to the float and double with the help of definitions of the float and double. Then moving forward in the video, we will also come to know about the format specifiers that are necessary for printing the values of float and double. And in the mid part of the video, we will see the precision of float and double, and we will came to know that we will come to know that this is the only factor which differentiate the float and double. So and at the end of the video, we will write some code in the Visual Studio IDE for our better understanding. So stay tuned with us and let's start our video. So coming on to the first topic, which is intro to float and double. So talking about float and double, what are these? As we already know that float and double are a type of data, or we can say that float and double is a data type in C, which is used to store fractional values like 6.45. So these data type are used to store the values of fraction or fractional values like 0.0, 6.45 and 5.0 and so on. And the syntax for float is as same as previous data types like int, as we have discussed in the tutorial number I think around 6, 7 or 8. So the syntax is float variable name, then we will initialize the value if as this is a data type of float, so we need to initialize with the fractional values because it takes fractional values in the variable. So we need to store initialize this value with any fractional number like 0.0, or either it can be 6.45 or either it can be 1.0. And coming on to the syntax for double, actually you will find that the it is somewhat similar syntax for the case of double also, just we need to replace the float with the double as we are using the double data type. So as double data type is also used to store the fractional values in the variable name, hence it will also take a fractional value to initialize itself. So we can use either 0.0 or 6.45 or 3.0 and so on. Moving forward in this video, now we'll talk about the format specifier for float and double, and which is same for both, and it is %f. So this is the format specifier for both, it is same, which is %f. So and the format specifier for long double is capital LF. Now you may confuse that what is long double now here, and it is also a member of the family of the float double only, you can say like that, and it also stores the fractional values just like a float and double. So what is the difference between these three, we'll came to know in the next slide. So next topic is on the precision for float and double. So as we have talked in the overview part that this is the only factor which is responsible for the differentiating the float and double and also long double also. So these three, that means float double and long double, differ each other on the basis of precise value. So how it differs? So if you want a fractional number with less precision, then you should or you can use float, because it is recommended and it is better to use float instead of double and long double. But on the double and long double will be also able to store this fractional values with precision, say less than or up to 6 to 7 decimal places. So we can use float double and long double in this case, but we prefer to use float because it will be better for us and for our practice. And suppose increasing your precision, if you want to do computations like like the fractional numbers which include 15 to 16 decimal places, precision up to 16 to 15 decimal places, then you should use double. again here you can use long double because the precision for long double is even more than this. In this case you cannot use the float. If you will use float, then you will get some garbage value or some random numbers at the end of the numbers or decimal numbers. So coming on to the next point, suppose you have a variable declared as float var1. So here we have a variable named var1. We have initialized with a value 5.67893. That means we have stored this fractional value in the variable name var1. Now suppose that you don't need to print this value up to this much precision or this much decimal places. Now suppose for the case that you want to just print up to 2 decimal places, that means you want to print only 5.67, but you have stored the value of var1 as 5.67893. So to print this value from var1, we can use another format specifier for this, which is %.2f. Here 2 represents the precision after the decimal. That means here we need 2 decimal places, we need precision up to 2 decimal places, so we will put 2 here. If we want to print 5.678, which is 3 decimal places, we'll put 3 here. Here dot is very important, and f is for float only. So that's all about the precisions of. So till now we have seen that what are the float and double, and what are the format specifiers for float and double, and we also see some extra theory part and that how they differ each other and what are the precision values for them. Now let's move to the Visual Studio Code and dirt our hand with some code and feel better and have a better understanding. So let's move to the Visual Studio Code. So here comes our Visual Studio Code. Now as it is tutorial number 9, so I will make a file with tutorial 9.c. So you can see here we have a tutorial number 9.c file. Now we'll write some code to understand better. So we'll include here header file. This is int main function, int main. Now suppose I want to define a variable of data type float, so I'll write like this: float var1 equals to, I have initialized with 0.0, and if you want to print this value, then you can see that we need, as we have discussed in the video, the format specifier for float is this, and we'll put the var1 here, and then we'll say everything went fine and return 0. Okay, I will save this file and compile here. So you should see tutorial 9.c. As you can see, it has compiled successfully. Now running this code, a.exe. It is taking some time, so let's wait for that. Now you can see that we have initialized var1 with only 0.0. That means only up to 1 decimal places, but the output which is coming is up to 4, 5, 6 decimal places. So this is by default. That means in this system or in the compiler part, it is by default that if you will print this value of var1, it will come up to 6 decimal places. So suppose that if you change this value and initialize it with 1.10, then let's try to compile it again and see up to what decimal places it is coming. Okay, so it has compiled successfully. Now run this. You can see again it has the same default decimal places, that is up to 6. So as we have discussed in our slides that the precision for float is about 6 to 7. So here in my laptop or in my architecture it is 6. Now if suppose here I have initialized this and I want to change here, like I want to add some number like 5, 1, 2, 3, 4, 5, 6, 7. Okay, as here you can see that the default decimal places is up to 6 only, but I have stored a value with decimal places up to 7. So let's just try it and try to print the value of var1 and see the output, that what is happening here. So if we'll compile this code and print this, so you can see here that it is printing up to 1, 2, 3, 4, 5, 6, up to here only. That was all about by default. So still it is giving default value only, default up to default decimal places only. Now if you want to use that format specifier, if you want to print up to 7 decimal places, because by default in this laptop it is up to 6 only. So if you want to print up to 7, then we have studied that we need like this format specifier. So let's try and save this code and compile, and you will see here I have compiled it. So if you can see here that the difference here is that we have 1 2 3 4 5 6 7 here, 1 2 3 4 5 6 5. So this 5 is a garbage value for this, because we know that the precision, the maximum precision for float is up to only 6 decimal places only, but we have stored a value with up to 7 decimal places in the var1 variable. So if you will try to print up to 7 decimal places, then you will get a garbage value, as we have discussed in our lecture slides. Now we have came to know this. Now you just want to print up to 2 decimal places, so just you want to put the format specify %.2f and just save this code and try to run it after compiling. Okay, so you can see here again you have compiled, and then you can see this here 5.12, because which is up to 2 decimal places only. So this is how it worked. And in case of things, so let's start. Suppose I declare a var1 as 0.0, okay, and I have an int as a equals to suppose 6 and int b equals to 11 here. Now just put the value of var1 as 6 or a by 7, sorry, a by b here, and just try it out, compile this and print the value of var1 here, as we are expecting the value point, because 6 by 11 is definitely will be in fractional number. So we'll use float part, and we'll use the format specifier for float also, and we'll say here say everything went fine, and then return 0 here. Now just save this code and try it out, and just figure out the solution for this. Now you can see here what it has printed, 0.00 up to 6 decimal places. So it is not giving the exact value of the 6 by 11, which should be not obviously to be 0.00. So what is happening here, as we know that here we have declared a variable which is of data type float, but here we are dealing with the variables which are of data type int. So we need to change this data type to the float. That means if you are dealing with floating point numbers, then you should use float for all others also. And now if you will change this up to float, then you will see that it will give the correct output. Now let's just try and compile this code. We have saved this code and just run this code. You can see now here it has given the exact value, that is 0.545455. Okay, so this is how we can see that how to deal with the float numbers, float data types. I hope you understood this. And now if suppose comment it out, this is all about, just comment it out. And now if you want to find the value of 6 by 11, okay, now just try it, compile the code, and you can see here it has compiled. And if you see the output, then again it will give 0.0, because it is a float data type, but here we are dealing with integer data type. So make it correct, what we need to implement is that we just need to put here 6.0, because it denotes that they are also a floating numbers. So we'll just save this code, and you will see that the output will be correct only, which is 0.545455 only. So this is how we deal with the float and double. So I hope that you understood this concept well about the floating and the double data types. In case if you like this video, then please subscribe and hit the bell icon for more updates. Thank you, and Jai Hind.